In our last video, we have studied about the definition of the electrical field. So regarding the definition of the electrical field, we got the relation, that is E vector is equal to 1 divided by 4 pi epsilon 0 Q divided by R square into R cap. So this expression provides both magnitude and direction. Both magnitude and direction. What about the magnitude then? Magnitude is modulus of E vector is equal to 1 divided by 4 pi epsilon 0 Q by R square. What about the direction? So in order to study about the direction, as well as in order to study about some of the major facts regarding this electrical field, we are going to study this in this video. That is, the first concept here is the important aspects of electric field. What are the important aspects of electrical field? Let us see. What is the important aspects of electrical field? Number one. So I am considering here the important factors of electrical field. When I am considering these important aspects of electrical field, let us take the point number 1. The point number 1 denotes the direction. Point number 1 denotes about the direction. The direction of the electrical field, is based on the source charge. Based on the source charge. The source charge means the charge that you have considered initially, Q. Another one is test charge Q0. If the source charge is plus Q, then the direction of electrical field is away. Electrical field is away from charge. Away from charge. Similarly, if the source charge is minus, negative charge or minus Q, then the direction of electrical field is towards the charge. Towards the charge. So diagrammatically we can represent. If the source charge is plus, or I am considering it as plus Q, direction of electrical field will be away from the charge. If the source charge that I have considered is negative charge, that is minus Q, then the direction of electrical field is towards that of the charge. This is the first question or the first point regarding the direction. Number 2. What is number 2? See, we have denoted that electrical field E is equal to F by Q0. Force per unit charge. From this, force acting on test charge is what? Force acting on test charge. What is the force acting on test charge? You just make a cross multiplication. You can write F is equal to E into Q0. If you are stating this F as F vector, then we have to say it out as E vector divided by Q0. This is considered to be point number 2. When you are considering this second point. Let us go for the third one. What is the third one? The third one is you have to calculate the magnitude of the electrical field. See, we can state like this. Magnitude of electrical field. Magnitude of electrical field is modulus of E vector. This modulus of E vector is independent of what? Is independent of the test charge. Independent of test charge Q0. But what it depends on? But it depends only on the source charge. But it depends on the source, or we can state it out as parental charge. Source charge or the parental charge. See, we can say the test charge is considered to be very small, so that the influence of the test charge won't affect the parental charge. That is the meaning of this. That is, see the dimensions or the test charge. Let us consider the magnitude. The test, when you are considering the test charge is very small point charge. You have to consider the test charge as very small point charge, so that the test charge won't affect. So that the test charge won't affect, or won't interact. We can say won't interact. Won't interact with what? Won't interact with the parental charge Q. So we are saying the magnitude of the electrical field is independent of the test charge, since the test charge is a small point charge. But it depends upon what? But it depends upon the source charge, or you can say it out as the parental charge. Okay, let us move on to what? Now let us move on to point number 4. What is this point number 4? Let us consider what is this point number 4. When you are considering this point number 4, we can state that electrical field available is inversely proportional to square of the distance. Electrical field is, okay, electrical field is inversely proportional to square of the distance. That is, as distance increases, what happens? The electrical field decreases. That is, as the distance between the source charge, and the test charge increases. Source charge and the test charge increases, then the electrical field go on decreases. How you can prove it out? We know electrical field E vector is equal to, or I can say modulus of E vector equal to 1 by 4 pi epsilon 0 Q by R square. Therefore, modulus of E vector is E, proportional to 1 by R square, or inversely proportional to 1 divided by R square. Then let us go for the point number 5. What is this point number 5? When you are considering the point number 5, since the electrical field is considering to be inversely proportional to the square of the distance, and if you are considering the positive charge, then the electrical field will be acting away, and if the point charge or the parental charge is negative, you can say it is towards whatever may be the distance from the parental charge, the test charge is being placed. Whatever small the test charge may be, no problem. See, I am representing it with the help of an diagram. Point number 5. I am having a positive charge plus Q. If I am considering some 2 or 3 points, one of the point is P here, another point is Q here, and one more point as R here. See, the distance between the 3 points are different. The first concept. The second concept is if I am placing the test charge at these points P, Q and R, which are under the influence of this charge plus Q, the electrical field at this point P is EP. Since the parental charge is positive, this electrical field acting will be away from this point charge or away from this positive charge. If you are considering here Q, then the electrical field available is EQ, which is also acting away from that of the parental charge. If I am considering R, then the electrical field is considered to be ER or ER vector, which is also acting away from that of what? Away from that of the positive charge. If the parental charge is considered to be minus Q, and if you are considering 3 points like this, if I am considering one of the point as P, another point as Q, another point as R, and at all these places, if I am having the test charge Q0, then what will happen? This P will, the test charge at this point P will develop an electrical field EP vector. At Q, the test charge will develop EQ vector, and at R it develops an vector called to be ER vector. Along what direction? Since the parental charge is considered to be negative, EP will be acting towards this negative charge, EQ will be acting towards this negative charge, and ER will also acting towards this negative charge. If it is positive charge, then the direction of EP, EQ and ER, all these are considered to act away from what? Considered to act away from the parental charge plus Q. Since the charge is positive, if you are considering this as negative charge, then this EP or this EQ or this ER, they will be acting in what direction? They will be acting towards that of the negative charge. So it is acting towards what? It is acting towards the charge. So this concept, we are calling it out as point number 5. What about point number 6? Point number 6 is, or we can state this point number 5 as, test charge Q0 is so small that it will not modify the electrical field or will not modify the electrical field of the source charge. See, for this 5th point, I can write an conclusion. What conclusion I can write for this 5th point? See, the conclusion that I can write is that if the test charge is so small, if the test charge that I am considering Q0 is so small, that is, I am taking it as the point charge, is so small that it will not modify the electrical field, will not modify the electrical field of source charge or parental charge. Are you clear? This is point number 5. What about point number 6? When you are considering point number 6, The electrical field that we have calculated is valid only for point charges. See, we know that electrical field E vector is equal to 1 divided by 4 pi epsilon 0 q by r square into r cap. This equation, okay, this equation is valid. This equation is valid only for what? Only for point charges. Is there any other charge available? Yes, the charges available in a sphere, or the charges available in a long rod, or the charges available in a disk. In that case, we will be calling it out as continuous distribution of charges. In that continuous distribution, we cannot apply this. See, this equation is valid only for point charge. If the charges are distributed, if the charges are distributed in a rod, linear rod, or a sphere, or a disc, etc., continuously, if they are distributed continuously, this equation won't hold good. We can't use this equation. This equation cannot be used. This equation cannot be considered or cannot be used. For that, integral, or we have to apply integral values or integrations in order to study about that. For that, integration should be applied. Integrations should be employed to study about all these things. So regarding that, we will be doing it in the next concept. How you can able to calculate the electrical field in case of continuous distribution. Okay, let us move on to the point number 7. What is this point number 7 now? When you are considering the point number 7, I can classify this electrical field into two. So electrical field is classified into two concepts. What are the two? One is uniform electrical field. And another one is non-uniform electrical field. What do you mean by uniform electrical field and what do you mean by non-uniform electrical field? If you are having a uniform electrical field, then inside that area, inside that field, at all points, the magnitude is considered to be same. See, again, let us draw it with the help of a diagram. If you are considering electrical field, this electrical field is classified into two types. One is, we are calling it out as uniform electrical field, or this can be considered as a constant electrical field. When you can able to say the electrical field as an uniform electrical field or constant electrical field, I can state this as uniform electrical field or constant electrical field if you are having the same electrical field at all points and acting in the same direction. See, if the field is said to be uniform, if you are having, if the electrical field available is same or constant at all points and acting in same direction, at all points and acting in same direction, same direction, then we are calling this as uniform, or you can say it out as constant electrical field. See how this uniform electrical field or constant electrical field can be represented. They are being represented like this. If you are drawing the diagram by considering the lines are electrical lines acting in the same direction and having a constant magnitude at all points, then that electrical field we are calling it out as what electrical field? Uniform electrical field or constant electrical field. And another one we are calling it out as non-uniform electrical field. What do you mean by this non-uniform electrical field? See, this non-uniform electrical field have different magnitudes. Okay, we'll be having different magnitudes and they are acting at different directions and acting at different directions inside the space or inside the field at different points. See, you compare these two. In case of non-uniform electric field, the magnitudes are considered to be in different directions and also acting in different directions at different points. But here, if the, you can write like this, if the magnitude of electrical field is same or constant and acting in same direction at all points, then it is called to be a uniform electrical field. How a non-uniform electrical field can be applied? A non-uniform field can be applied like this. Say like this. Then this is called to be a non-uniform electrical field. See, you can state an example for non-uniform electrical field. A point charge, produces a non-uniform electrical field. So a non-uniform electrical field can be produced by what? Produced by a point charge. Let us consider the point charge as plus Q. See, when you can consider non-uniformity, we can also state that. See, non-uniformity may be due to both changes or due to change in both magnitude and direction. Not only magnitude or not only direction, both in magnitude and in direction. Then also you can able to say the electrical field as non-uniform electrical field. These are considered to be the important aspects of the electrical field. Let us recall what you have studied here regarding this electrical or important aspects of electrical field. See, let us recall. Let us consider let us take the right from the first point. See, when you are considering the first point, you see here the electrical field E is given by the formula 1 divided by 4 pi epsilon 0 Q by R square. This gives you the magnitude. You just go with the cursor. And here we have to calculate what is the direction. So in order to study about that, let us go for the important aspects. The direction of the electrical field is based on the source charge and not depending on the test charge. Okay, it is depending on the source charge and not depending on the test charge. So if the source charge is plus Q, positive, then the direction of electrical field is away from the charge. I have drawn it here. If the minus Q, if the source charge or the parental charge is minus Q, then the direction of the electrical field is towards the charge. Here the diagram. You look at the cursor, movement of the cursor, it will be easier for you to follow me. So the next point. See, the second one we know in general, the magnitude of the electrical field E is equal to F by Q0. So what is the force experienced on Q0? You make a cross multiplication, you can get force experienced on the test charge E is equal to, or F is equal to E into Q0. So I can write F vector is equal to F vector is equal to E divided by Q0. I can represent it as Newton. The unit is Newton. Then the magnitude of what? The magnitude of the electrical field E vector. See, the magnitude of the electrical field E vector is independent of the test charge because the formula is not including Q0, but it depends upon the source, that is the parental charge. Since the test charge is very small, or it is considered to be a point charge, it is very small point charge, so that the test charge won't have any effect or interact with that charge Q. Then point number 4, electrical field is inversely proportional to square of the distance. You just look at this formula. E vector is equal to, or modulus of E vector is equal to, what is this? Modulus of E vector is equal to 1 by 4 pi epsilon 0 into Q by R square. So I can state that E vector is, or modulus of E is inversely proportional to square of what? Square of the distance. Then point number 5. See, for studying this point number 5, let us go with the conclusion first of all. If the test charge Q0 is small, so that it will not modify the electrical field of the source charge. See, if I want to calculate the electrical field of this source charge plus Q, I am considering 3 points. One as P, another one as Q, another one as R. Now, on this P, the electrical field is EP. On this Q, electrical field is EQ, and R, it is ER. Since the source charge is positive, what is the direction of this electrical field at these points? The point charge is available at these points is not modifying the direction or the magnitude. See, it is given as, since the source charge is positive, it is acting away from that of what? Away from that of the source charge. Similarly here, if you are considering the negative charge and they are considering 3 points, one as P, another one as Q, another one as R. At point P, you are having the electrical field as EP. At Q, EQ, at R, ER. Since the source charge is negative, the magnitude of these electrical fields are acting towards that of the charge. So, in general, we can say if the charge is positive, then direction of electrical field, okay, direction of electrical field is away from the charge. If it is minus, if the charge is negative, then it will be acting towards the charges. So that is the conclusion. Then let us go for the point number 6. What is that point number 6? See, if you are considering the electrical field, see, E vector is equal to 1 by 4 pi epsilon 0 into Q by R square R cap. This equation for electrical field is valid only for a point charge. You may have a long rod where you are having the charges can be distributed continuously, or you may have a sphere where the charges can be distributed continuously. In that case, that is what I have written. If you are having a linear rod, long rod, or a sphere, or a disc, we cannot apply, or we say this equation is not applicable. If you want to calculate electrical field for these continuous distribution, we have to apply integral method. Using the integration process, we have to study about that. That we will be doing it in our next forthcoming videos. Then the next and the final point is, see, the electrical field available in this universe can be classified under two headings. One is uniform electrical field and another one is non-uniform electrical field. That is what I have written it here. If you are considering electrical field, one is a uniform electrical field or a constant electrical field, and another one is a non-uniform electrical field. When you can say that electrical field is uniform, see, you are having a charge and around that charge you are having a field. You consider any point inside that field or in that area, at all these points, at all these different points, the magnitude of the electrical field is same, and all that electrical field will be acting in the same direction. Then that electrical field, we are calling it out as uniform electrical field, and our constant electrical field usually represented like this by drawing parallel lines with arrowheads along the same direction. When you are considering the non-uniform electrical field, the same concept or the same diagram that I can consider. See, you are having a charge Q, and around that charge Q you are having different points, and if you are considering different points in that field, and if the electrical fields are acting in different directions or different magnitudes, or both changing, both magnitude as well as the direction are considered to be different at different points inside the field, then it is called to be a non-uniform electrical field. So I have given the definition like this. Non-uniform electrical field will have different magnitudes, and that magnitudes are acting at different directions at different points. Also, we can state like this: non-uniformity or non-uniform electrical field is said to be a non-uniform, or non-uniform. It occurs with non-uniformity when both magnitude as well as the direction of the electrical field is changing or is different at different points. These are called to be the important aspects of electrical field. Similarly, another important question, you may be asked it for a 5-mark question stating that define electrical field and list out the important aspects of the electrical field. Let us see in the next video. Thank you. All the best.